Welcome, my friends. I am Mr. Bulaki Bhavashu, Abasad Marathi Arts and New Commerce Science College, Rajapur. We have seen in this lectures alkyl halides. Alkyl halides, the saturated carbons which is attached to the halogens are named as alkyl halides. So, in these chapters, we have studied the various types of mechanisms and their reactions. Three types of mechanisms are studied in the chapters. First one, SN2 mechanism. Next one, SN1 mechanism. And third one is SNI mechanism. Now, first mechanism like SN2, we have C. So, SN2, nucleophilic substitution reaction of that alkyl halides. So, SN2, what is meant by SN2? SN2 is a substitution nucleophilic bimolecular reactions. Now, the example of that SN2 reaction is like this. To taken the methyl bromide in presence of the NaOH and to use the Br is replaced by OH as an alcohol. So, in this reaction, the halide is replaced by the OH or the substitution reactions, and also the kinetic factors also we have seen of that mechanisms. It is a SN2 means that the rate of the reactions which depends on the both, that is the substrate as well as the nucleophile, and therefore it is a SN2 reaction. Then which type of mechanism is operate in this mechanism? See here in these examples, it is general alkyl halides we have take. This incoming nucleophiles which is attack on backsides and the leaving group is displaced from the front side. That time what happens? The nucleophile and carbons is partially form the bonds. Similarly, the carbon and X bond it is partially breaking. It's transition state, and after displace this leaving group to form these the products, or the simultaneous type of mechanism are operate in this reaction. The CBr bond is polar and therefore the nucleophile displays the leaving group which is approach the carbon from the backside. The simultaneous the nucleophile attack and displace the halide are take place. Therefore, rapidly elimination are occur in this inversion of configuration take place. The next point we have see the energy profile diagram. Energy profile diagram are clearly indicate that how the reaction can be changed. Like it is a primary alkyl halides and their nucleophiles in the reactants. It go to the transition state to partially form this nucleophile OH and the carbon bond and the bromide and CS or C bond. That time what happen? Energy between the reactants and product it will be increased. Then after lose the bromide ion to get the product is a alcohol. Our clear shows that the potential energy of that product will be less. That is reactant are converted to the products. The energy will be decreases. The next point we have see this mechanism or the stereochemistry. How will you change the stereochemistry of that mechanism? We are observed in these reactions. For examples, the chlorosulfonic acids or the malic acid, it can be interconverted by the nucleophilic substitution reactions. In these reactions, the one of the ionisomers is converted to another by substitution the chiral carbon, and this reaction are named as a Walden type of inversion are occurs. Means that in these examples, this chlorosulfonic acid or chlorosulfonic acid, which is interconvert to the nucleophilic substitution products, means that it is OH, that is nucleophile, is attacked from opposite to the leaving group, and there will be change their optical activity or change their configuration. This is a, if we consider this R configuration, then naming the product is a configuration occur in this mechanism. Next point, hydrolysis of 2-bromo-octane 2 gives 2-octanol having a different configuration. It is another example. It is a 2-bromo-octane gives 2-octanol having a different configuration. We will see that in this mechanism in the one-step reaction, because simultaneous bond breaking and bond making are take place. In this reaction, the backside attack of backside and form partially bond between the COH and partially breaking the bond CBr leaving group take place. This three group becomes coplanar when CO bond are completely formed at the same time. The CBr bond breaking simultaneously take place. In such a process are occur in such a process are occurs without any intermediate. The final product which is obtained is 100% inversion of configurations are occur in SN2 reaction. For examples, this type of pictures are clear that in this 2-bromo-octane we have tritene silver hydroxide. That time what happens? This OH is a nucleophile attack from backside and to form the partially bond, and that time the CBr bond is partially ionized, and next time then what happens? The leaving group bromide is replaced and to form this COH bond completely with 100% inversion of configuration. Then next scientist Hugs are clearly identify or study how will you change the configuration. 100% inversion of configuration are occur, which is used as the 2-iodooctane optically active are treated with the radioactive sodium iodide. It is observed that in this reaction not only exchange the ordinary iodide but also the lose their optical activity. What's twice? Means that it is concluded that the labeled iodide it attack from backside and pass this type of transition state, tetrahedral transition state, and invert of that configurations are occur in this mechanism. Means that his optical activity is lost as a twice is shown by it is backside attack of these labeled iodide are take place are clearly explained in Hugg's experiment. Thanks.